welcome. In this edition of Algorithms and Data Structures tutorial series, we are going to talk about one of the known insertion sort algorithm version, and show some modified versions of this algorithm. What are the modified versions of insertion sort? The first modified version is called shell sort. The second version is called address calculation sort. We will discuss them in other tutorial videos. Today we will focus on the normal insertion sort version. Suppose we have a set of unsorted integers 8013. And we want to sort them in increasing order. We will start from element number 1, that is the key. And we'll keep looping if j is greater than or equal 0. And the element in index j is greater than the key. If loop condition is satisfied, the element in index j will be placed at index j plus 1. And j will be de-incremented by 1, and the key will be placed at index j plus 1. We will repeat this process until the index reaches n. In our case, we will start from index 1 and store the value of the index in integer key. Then we will check if the loop condition is satisfied, that is 8 is greater than 0. Then 8 will be placed at index 1 and 0 in index 0. In the next pass the key is 1. Then we will check if the loop condition is satisfied, that is 8 is greater than 1. So 8 will be placed in index 2. Then j will be de-incremented by 1. Then we will check if the loop condition is satisfied, that is 0 is greater than 1. And we will exit the loop and place the key in index 1. In the final pass the key is 3. Then we will check if the loop condition is satisfied, that is 8 is greater than 3. So 8 will be placed in index 3. Then j will be de-incremented by 1. Then we will check if the loop condition is satisfied, that is 1 is greater than 3. And we will exit the loop and place the key in index 2. Now we have a sorted set in increasing order using insertion sort algorithm. Analysis. Worst case occurs when the inner loop has to move all elements, which happen when the element in index j is smaller than all the other elements, with time complexity of big O of n squared. Average case occurs when the inner loop inserts elements in the middle, with time complexity of big O of n squared. Best case, when the set is almost sorted, time complexity will be big O of n. Advantages: simple implementation, efficient for small data, more efficient than bubble sort and selection sort. Adaptive: if the input is almost sorted, time complexity will be big O of n. Thanks for watching. Don't forget to like and subscribe for more programming videos. See you in the next video.